This is a bit of comparative analysis of the output waveforms of 3 different lamps. The lamps in question are a 15 watt General Electric Chinese GLS 12.5 watt Philips LED lamp and a 13 watt green light there. And that thing right there is just an isolation transformer for safety because 120 volts, blah blah blah. And also for the mains reference, I am using a 100x probe. The waveforms in question are the yellow one is the mains. The light blue, which is looks kind of greenish on camera, but that's the compact fluorescent. Purple is the LED, and the dark blue, which actually does look blue on camera, is the incandescent lamp. All that noise, by the way, is just an artifact from the that is just noise imposed by the LED. And those are the current per division scales. By the way, this is a feature that lots of higher end scopes have, is the ability to set units on the output. Like for example, channel 4 units, amperes. You could also have watts, amperes, volts, and I'm guessing U is probably an arbitrary unit. Let's see if it won't change anything. Yeah, milli-units. Yeah. Amperes, milliwatts, yeah. I'm guessing that's just, yeah, arbitrary units or something. But anyways, yeah, you can see, by the way, this is one annoying thing about the Rigol scopes, is the colors, because those can be kind of hard to differentiate, especially if you do, get rid of the menus on the intensive reading words. If you, actually if you dim it, it doesn't really change it that much. But, I mean, yeah, they're perfectly discernible, but this is where having something like a green and a reddish magenta color, like most 4-channel scopes, would be useful. But this is also where a 4-channel scope is actually useful, because you can do this measurement for 3 different things at once. But yeah, there's a bit of trigger jitter, but a lot of that is just the noise from the LED, which is extremely noisy. Let's just zoom in on that. Also say that at 500 milliamperes per division, and the cursor manual. Get more of the screen shot. See what I'm doing. Yeah, the peak current from the compact fluorescent lamp is about 670, almost 700 milliamperes, which is fairly typical. Let's see. I'll say it's the peak is 276 milliamperes, but there's still that great deal of noise, which boosts it up to peak current of 330-ish milliamperes, or 340 milliamperes. And the incandescent is channel 4. That peak current is 200 milliamperes, which is roughly what you'd expect. Or no, 190, which is, yeah, what you'd expect from a 15 watt lamp. Yes, I know the 15 watt incandescent wouldn't be nearly as bright as a comparable fluorescent or LED, but this is so that the power consumption is roughly similar between the various lamps. So yeah, let's see, cursors off, bye-bye. Get rid of the menu. Yeah, Feeling nasty waveform. I'm actually going to get a better look at that. And this is the peak current from the fluorescent lamp, about 700 milliamperes-ish. So they're fairly high. And what that is that's the inrush when the potential across the filter capacitor becomes less than the supplied mains or the instantaneous potential of the main supply, and as a result there's a sudden current spike as the capacitor charges. You can see it's enough that it's actually dragging down the potential of the main supply there, because this is being measured on the secondary, the output transformer, and that is a 250 volt ampere isolation transformer, so not insignificant there. And and of course this current spike, which is already fairly high, is exacerbated by things like dimmers or solid state switches. So this could be very easily in the amperes, because you can see even with nothing, and even with the inductance of the isolation transformer limiting the current spike, it's still, you know, over 700 milliamperes for a 13 watt lamp. And then of course you can see it drops precipitously until it kind of levels off at the peak, because there is that flat topping is normal with mains as of about 40 odd years ago, when electronic loads started becoming prevalent, and because on the grid you've got billions and billions of loads with current profiles like that, and that's why it looks kind of like absolute crap. So yeah. Okay, well anyways, there's a anyways, this is the output, or this is the line current draw of the 12.5 watt Philips LED lamp, and fairly noisy, and also somewhat kind of jagged. You can see there's this region where it isn't drawing all that much, or very little, except for all this noise, which is, I think, the actual LED driver circuit. So what it may be is that there's a separate power supply and LED driver, although the teardown of one of these lamps that I have seen didn't go into a huge amount of detail as far as the actual schematic. But then again, considering the complexity of one of these lamps and multi-layer PCB, or more than 2-layer PCBs that are absolutely stuffed with components, it'd be very hard to do that. But I'm guessing that probably a lot of this noise is just either a separate LED driver or the switcher just operating but not really drawing it much current from the supply, and just kind of operating off of its internal ripple suppression capacitors. But see there at about 84 volts, because I measured that with the cursors, there's a current goes from near zero to a peak of 200 something milliamperes over the range of about 260 milliamperes. And as the instantaneous potential goes above 84 volts, there's a bit of a current increase, and there's a sudden increase, kind of a bit of a hitch at where the main supply flat tops, another increase, and then it levels off, presumably as the capacitor's finishing charging, levels off again for the remainder of the flat top, then it goes down with the instantaneous mains potential until the switcher stops drawing current at about 84 volts. And there's a huge amount of noise on this. Let's see. Okay. Let's see. Yeah, there's all kinds of scragglies in there, but let's see. This looks to be the main frequency, and that might be just, I don't know if that might be harmonics or something, but cursor 1. No, I want X-cursors. Let's do 1, 2, 3. Let's say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Just for a bit more accuracy, but yeah, the delta. And over 10 periods of the switcher, which I've kind of zoomed in on, delta T is 10.87 kilocycles, so that's about 108, so roughly about 110 kilocycles is the main operating frequency of the switcher and the lamp. And if I run the acquisition again, oh crap, segmented memory mode, that's how I could get it triggered. But yeah, it's very noisy. I mean, I'd imagine that probably a lot of that isn't really fluctuations in the current supply, but I don't know, could be. I know these things generate a huge amount of QRM, because a lot of the, I think the 7th, yeah, about really the 6th through 16th harmonics of that are all in the AM broadcast band, so yeah, these things would probably require a decent amount of filtering. And this is the JLS lamp, and as you can see, it looks to be a fairly clean, or as clean as the circumstances can permit, sinusoid. Fairly closely tracks the mains potential. Looks to be a bit of variation, but actually take advantage of the vernier and yeah, there is a little bit of a variation there, but that is just due to the nonlinear resistance of the filament. Is that as the filament is heating up during this point, which of course leads to the filament resistance filament resistance increasing, so the current decreases, which is what can be seen right there. But it's fairly closely matching, and let's see. Yeah, a bit of a difference, but nothing excessive, and of course there's virtually no noise. A lot of that is just pull the EMI from the screen. Yeah, again, this is a fairly unoptimal setup right there. You can see just again, by the way, don't try this at home. Risk of electrocution, blah blah blah. Running through an isolation transformer, do not attempt. Those are just a couple of 1 ohm 10 watt resistors that I'm using as current shunts, because it's more accurate than the Herpaderp current probe that I made out of just a spare toroid and some wire that I've shown in previous videos. So yeah, don't attempt, risk of electrocution, blah blah blah. You know the drill. Doing these things so you don't have to, etc. Do not attempt, you know, the usual. And the advantages of a 4-channel scope, like I'm with.